Hi guys, in this video I'll give an overview of what GraphQL is, why it is useful, and how to use it. So without further delay, let's begin. Okay, so GraphQL can be thought of as an intermediary layer between the front end and back end of traditional client-server applications. It's mainly a query language. So a query language is basically a language that you can use to get stuff. So basically querying a database, if you're familiar with database uh, applications in using SQL. It's basically like that. You're querying something, you're getting something. Query language is a specialized programming language for searching and changing the contents of a database. Not just a database, it could be anything that you use to store data. It is also considered a runtime environment, that is a software that provides the application to be run in a more convenient environment for execution, which GraphQL certainly does. And primarily, GraphQL executes queries using a custom type system that defines the application data. Therefore, it's important to note that GraphQL is not linked or associated with any particular database technology, such as MySQL, PostgreSQL, MongoDB. So it's not a database technology. It's more like tool that is used to query from any particular database technology, okay? And or a storage engine like AWS S3 buckets. Instead, it's only supported by the existing code in the user's front end and back end applications and the data they contain. Um, GraphQL was developed as an alternative to traditional REST APIs,
QL
and
executes
uh, it's because traditional REST APIs often get convoluted, tedious, and cumbersome when adding additional features and introducing more and more complexity over time. So GraphQL was designed as a way to overcome these flaws. For example, if you use a REST API to fetch data, it'll always return a complete data set, right? So request calling for two objects would require two API requests. This causes inefficiencies when dealing with requests on a large scale, which is all too common these days. Also, the inefficiency known as overfetching, whereby a request to a REST API returns the desired properties of an object along with the redundant properties, is all too prevalent when using REST APIs. GraphQL, on the other hand, streamlines this process a lot more by only returning the object properties that are specified in the given request, so that only the properties that are desired are returned and all the fluff and all the redundant properties are excluded, which makes these request response cycles much more efficient and effective. This feature also extends to entities of different types, so that objects of multiple entity types can be returned in the same request as long as a matching query is defined by the developer. So let me give an example of what I mean. So here's my blog post where you can, on Medium, where you can check it out. What this example is showing, and what it's basically doing is, so you have an airplane, and it's saying get the airplane with an ID of 3, get its ID, model, size, and passengers. Now, passengers is an object type, meaning that it itself is an object that contains properties. So you have ID, name, email, and carry-on baggage. And then if we go down further, carry-on baggage is its own object type, and it contains its ID, weight, baggage brand, and color. So what we're basically doing here is we're getting an airplane's model, size, ID, and the list of passengers it carries along with their carry-on baggage information, and the passengers, you'll notice, has square brackets. This indicates that this is to be a list of passengers instead of a single one, because more than one passenger can ride an airplane. And basically, you can see there's one, two, three object types that are being fetched from this single GraphQL query. You couldn't do this in a traditional REST API. For example, here's a cool Google image I found showing traditional REST API. So let's say you wanted to get a user with a specific ID and then get their followers as well, the amount of all the followers they have. To do this, using a traditional REST API, you'd need three separate API request response cycles. So you need to get the ID first, then you need to get the post ID, and then you need to get post, you need to query post, and then you need to get the followers. So three separate requests to get the information that is required. Now let's look at GraphQL. So same example. So you have the user with this ID. This is the query. So it's saying I want the name of the user. I want all posts that they've posted along with the title of that post. Um, and the last three followers they have, and give me the name of those followers, and you just send it to GraphQL. GraphQL queries the database or the API and returns that information back to the client. Now that client has the username, post title, followers, and a list of followers, all done in a single request. So this is the advantage of GraphQL, is it simplifies, it makes it more efficient, and it's much more streamlined under this GraphQL querying process. So moving on to GraphQL operations. So there's three main operations that are primarily used in GraphQL, and the first one is queries. So a GraphQL query is used to read and fetch data from an API. GraphQL queries differ from traditional REST API requests because they allow for more customization in terms of the fields and properties that should be returned by a given query. In other words, they prevent data overfetching. To show an example of this, let's say we have this query and we're querying for a number of tweets, and we're getting the title, body, author of that tweet, the first name and last name, and the published date. This author field is a different object type. So this is a user object type, and it's you're able to get the first and last name using a single query, which you wouldn't be able to do using a traditional REST API. Also note that queries are implemented via HTTP post requests that are sent from the client, goes through GraphQL, and finally comes to the backend or database implementation. So there's no magic here. Um, Next, we can move on to mutations. So mutations are the second type of operation in GraphQL. And basically, mutations are used to write or post data to an API. They're analogous to post, patch, or put request in terms of traditional REST API calls, where GraphQL mutations have the upper hand over those traditional put requests is when dealing with complex and nested relationships in the domain layer. This is because updating values through mutations is much easier than having to create nested REST endpoints, as you would have to do if you chose the traditional REST API architecture. It's also worth noting that mutations allow for values to be returned after the data updating has been taken place, which effectively eliminates the need for a subsequent query to be run. So it basically updates a value and then it returns a value as well. So it's a two-in-one. I'll give an example of a query here. So we have this query, or I can actually show you uh, this. Yeah, I'll show you this. So we have create tweet, and you have a string as a title, body, published, and author ID. And we're calling the create tweet method that we've defined in our GraphQL schema. Uh, and we're passing it this data. And then as a response, we're expecting this data. So we're saying create this tweet with the data that you have here, and then return the title, body, authors, first name, last name, and publish date. So I'll give you a solid actual implementation using a example project that I have here. So we have create tweet, and this is the schema that's used to define this mutation, and create tweet is defined here, and basically it takes at create tweet input as input. So you can see here it has an input type, and this basically means I want data to be inputted in this specific format and nothing else. So I want title, body, published and author, and it needs to be in these types. And then we pass that data to the create user method, and then we expect a user return type. And I'll go into more detail in a later section, but that's basically what a GraphQL mutation does. It takes takes in some data, modifies that data, or creates new data, or creates a new value, and then returns some data. And next, oh, sorry. So in mutations, yeah, so it returns some data. And then keep in mind that GraphQL mutations are also implemented as HTTP post requests. So there's no magic or anything magical about GraphQL. It's leveraging already existing HTTP and WebSocket protocols. And the WebSocket protocol will come into play in this next section, which is the subscriptions. So subscription is the third type of operation in GraphQL, and subscriptions are similar to queries with the additional benefit of being long-lasting operations. So think of subscriptions as subscriptions to a YouTube channel, where you can subscribe to a YouTube channel, and every person that subscribes to a specific YouTube channel will get notified when the YouTuber releases a new video. So basically, you're basically listening to a response to come, and that connection, that listening action is long lasting. It lasts for a long time, and it's basically listening until a response is received. So they can uphold an active connection to the GraphQL server, which allows the server to push real-time updates to the subscription, which is then passed to the client as well. Where subscriptions excel is instances where the server needs to be notified, um, needs to notify the client of data changes that are happening at almost instantaneous speeds. And I'll give some examples of this later. So accordingly, some practical uses of GraphQL subscriptions may include services that you're already familiar with, such as think about in a Facebook Live session where you see the amount of likes that are happening as icons that emanate from the bottom. Um, that's all done through GraphQL subscriptions. So it's basically a WebSocket connection that actively listens for likes that are pressed by the users at real time, which the server is then notifying the clients of. Uh, Similarly, any Instagram live sessions where you're giving a live feedback in the form of likes or hearts or comments even are all done through GraphQL subscriptions. Some further examples could be I know Uber uses GraphQL, and they probably use GraphQL subscriptions as well. Any type of chat scenario where you have real-time updating, so WhatsApp, services like that use GraphQL subscriptions extensively. So now let's give an example of a subscription. So subscription, so you can see it's defined as a subscription, and you're basically saying we want a tweet and we want the mutation type, and the data should be a title, body, author's first name, last name, and published. So this mutation right here is, let's see if I have an example of this. Um, Yeah, so here we have a subscription and we have a tweet and we have a tweet subscription payload. And that's basically the body of whatever thing we want. And we have a mutation. So you might be wondering, what's a mutation doing in a subscription? So a mutation is basically an enum that we've defined up here. And an enum is basically something that's constraining the number of values you can output. So it's basically saying the number of values should be either one of these three options. It cannot be anything outside of these three. And so the mutation type can be either created, deleted, or updated. And in the tweet subscription payload, so a tweet can either be created, deleted, or updated, and the data would be a tweet itself. So if we trace tweet, we can see that it's also an object type that contains an ID, title, body, published, author, which is a user, and the user is defined up here, having ID, first name, last name, email, age, tweets. So it also defines a list of tweets that the user has and some comments. So comments are defined down here. So ID text author, which is a user, and the tweet that comment was commented on as a tweet object. So as you saw there, it's all interrelated. And what this subscription is doing is that it's giving back a tweet object along with the mutation type. So was that tweet created, updated, or deleted? We need to know the mutation type using that enum I showed you. And then the data, which is the title. So what's the title of the tweet, body, authors, who was the author that published this tweet, and was it published or not, which is a Boolean value. So like the above code we see here, it publishes, it adds a subscription to the tweet channel and starts listening to any events published in that channel. Finally, it's worth noting that GraphQL subscriptions are implemented as WebSocket connections. So WebSockets are an existing and probably pretty old technology, but very reliable nonetheless. And it's basically full duplex communication channels over a single TCP connection. Many chat applications use and leverage WebSockets because they allow for instantaneous communication, and that's what GraphQL subscriptions use under the hood. So there's no magic there. And then we have the GraphQL schema definition language. So let me see if we can pull this up. Schema definition language. Yeah, so the schema definition language is basically a um, so far we've discussed two main concepts in um, we've only discussed one main concept in GraphQL, and that was the query language. But there's another type of language in GraphQL called the schema definition language, or SDL. And the schema definition language can be thought of as a language used to define the schema that GraphQL uses and store it as a string while making sure to preserve it in human readable content format. A schema defines a collection of data types on top of specifying relationships that exist between those data types. So I'll give an example of a GraphQL schema. So right here, that's a schema right there. So if we go here, yeah, so this entire file, schema.graphql, is one giant GraphQL schema. So all of this can be considered a GraphQL schema because it defines the object types but does not provide a actual implementation. It's an abstraction and defines the relationships between these types. For example, a user has has a list of tweets, and a comment only has one user. It cannot have multiple authors. So that's what it's meant by defining relationships. And every field defined in the schema consists of scalar and object data types. So a scalar type can be considered a traditional type where it's ID, string, int, or boolean. Those are scalar types. And then there's also object types, and an object type is basically tweet, comment, uh, user. These are all object types because these are not um, inherently defined by GraphQL. We just define them on the fly, like here. So to put it in a nice analogy, scalar types can be thought of as primitive types in Java, C, Python, languages like that that have built-in primitive types. That's what scalar types are analogous to. And then object types can be thought of as custom classes or custom class types that are defined also in traditional programming languages. So those are some examples of the types of data types that can be used in GraphQL. There's actually many more GraphQL data types. Let me see if I can. GraphQL data types, basic data types, schema, and yeah, so there's scalar types, enumeration types, lists, interfaces, as you see an interface, union types, and input types. So we've briefly touched upon input types and a bit more, but yeah, that's what it means. Now you might be wondering what this exclamation mark is doing. So basically it's saying that that field is non-nullable. Non-nullable means that it cannot contain null values. It must contain a value that is not null, and ideally it should contain a value that is uh, of the type ID. Another point worth clarifying is this bracket syntax, the square bracket syntax, and that basically denotes a list of something. So this comments field requires a list of comment objects, and so it's pretty straightforward. And what when we have double exclamation points right here, we're saying that this list should contain at least one comment, and that list of comments should be not null. So both of these things cannot be null. Whether that's syntactically or logically correct is a different question, but I think it should be like this, so that the list cannot be not null, but there can be a tweet can have 0 comments, and that's a valid tweet, right? So we have to think about logic as well as syntax when we're designing our schema. Yeah, so that's basically, uh, although let me briefly touch upon resolvers. So we've defined all our mutations right here, right? And our queries right here in our schema. But now you might be wondering, but we haven't given a specific implementation. We haven't defined how to create a user. We haven't defined how to delete a user or get these users, right? And that's what resolvers are for. So a resolver is basically something that helps resolve the value or type of GraphQL objects. So if you want to think of a traditional REST um, web application scenario, they're like controllers in web applications when you're building out traditional REST APIs, in that they resolve a value for any type of the fields defined in the schema. For example, we have a resolvers folder right here, and we have a mutation. So over here we have the create tweet method, and in mutations we have the create tweet method, which is defined right here. So this is the actual implementation of that method, and this is where the actual logic is written. So if first find a user with the same user ID, then create the tweet using the data that was passed in through args. And if that tweet is published, then make sure that the mutation type for that tweet is created. So right here, that's a GraphQL subscription that's taking place because we're using PubSub. So PubSub is a class that exposes a simple publish and subscribe API, and we're giving this tweet the mutation created because if a tweet was published, we want a new tweet to be published. We want a new tweet to be created with the data being this tweet object that was newly created, with the ID being randomly regenerated because we want the new tweet to have a new ID, not the old one. And then once that tweet is created, we use PubSub to send a subscription call or response to the client that is listening on the other end, and then we return that tweet. So as you saw there, this is the solid implementation. This is the actual nitty-gritty implementation of how to get how to implement those things we defined in our schema. And we can see for queries, if we want to get the users, we're saying in DB, go to our database, query all the users, filter them, return their names in lowercase if it matches the query. So this is a search by ID type method where it returns the ID that matches a user in a given database. And that's basically what resolvers do. They help resolve a value in GraphQL. So yeah, that basically wraps up my video on an introduction to GraphQL. Again, this is only an introduction. There's a lot more to GraphQL to be learned, and hopefully I'll create more videos on GraphQL in the future. Let me know if you like these types of videos. I know they're helpful for me because I get to learn this stuff and create videos for them. And I hope you were able to learn something as well. I'll attach any supporting links such as my blog post, my code example, in the video description so you can have an opportunity to learn them. And if you found this video helpful, please make sure to like and subscribe. Thanks again for watching my video and see you in the next one.